So a bit of a geometry problem solving one we've got here. Question 22, so they're getting a little bit tough. There's a bit of thought involved in these ones. Two circles, one of radius 1 and the other of radius 2, touch externally at the point P. We've got a diagram given to us, very nice. Straight line cuts the area formed by these two circles in the ratio 1:2. So the area underneath is 1, the area above is 2. In what ratio does this line cut the area of the smaller circle? We're dealing with areas here, and what do we know about areas? They are two-dimensional. So the area of this little circle is actually only 1/4 of the area of the large circle. How do I know that? Well, the area of the little one is just going to be pi times r squared. Well, r is 1, so the area is just going to be pi. The area of the large one, pi times 2 squared, pi r squared for the area, pi times 2 squared is 4 pi. So the area of the small one to the large one is pi is to 4 pi. That's my first little step. The next thing I'm going to do is I'm going to put in the center of the circle for each one. Now, obviously, I'm not drawing this to scale, but it's going to give me one little bit of information that's going to help me find the answer to these. If I put the center of the circle in there, we have vertically opposite angles here and here. What does that mean? We have, because these are within a circle and these are both radii, that's an isosceles triangle. So this angle here will equal the opposite angle, which equals that angle. And again, these radii are equal. So I've got 4 angles all being equal to each other. What does that mean? Here's the important bit. The angle in the middle is the same. Why is that important? Because now, if I do a little bit of shading here, the proportion that red area occupies of the first circle is exactly the same as the proportion the red area occupies of the larger second circle. Great. Let's call that very creatively A. So that's going to be area A. The other bit is going to be B. Fantastic. Now that's a ratio. So if this is A is to B, this circle here, remember, is 4 times the area. So if I call the actual area A and this area B, then the corresponding one, this is going to be 4 times A. This area will be 4 times as large as the other one. They're going to be in proportion, so it'll be the same ratio, and this one's going to be 4 times B. Both of them are going to be 4 times larger in the second circle than they were in the first circle. Now we can use the last bit of information they gave us, which is that the area of one part to the area of the other part. So this bit underneath is obviously the smaller area, so B plus 4A, it's been split into the ratio 1:2. So B over 4A and the other area A plus 4B. Now here's the catch. If the ratio is 1:2, I'm going to need to double this area to make them equal, aren't I? So the area underneath the line, if you like, underneath the line, the smaller area, if I double it, I'll end up with a large area because the ratio 1:2, to make it the same size as the right-hand bit, I need to double it. We've got an equation we can solve almost here. It's obviously got one variable, but we can find a ratio. So let's keep going. 2B plus 8A, expanding my bracket, is equal to A plus 4B. I'm going to collect all my A's on the left and all my B's on the right because that's going to keep everything positive, which makes it nice and easy. Subtracting A from each side, I've got 7A on the left. Subtracting 2B from each side, I've got 7 times A is equal to 2 times B. Okay, what are we trying to find? What ratio does the line cut the area of the small circle? I really want to find B is to A or A is to B, whichever way you want to find it. If we do that here, 7A over 2 is equal to B. And of course, if I want to get that as B over A, it's just as easy. 7 over 2 is equal to B over A. So the ratio of B divided by A is 7 divided by 2. If I wanted to write it the other way, A is to B is 2 is to 7. That would be the ratio of the areas. So that gives me the answer D. That is a pretty tricky question. I'm not going to kid you. That one's a little bit tricky. You've got to realize that when you're dealing with an area, once you've got a length and it's in a ratio, the ratio for the area is the square of the ratio of the length because areas are two-dimensional. Once you've done that, it becomes a little bit easier. Maybe you could get away with just assuming they've been broken up into the same ratio without having to find these angles and prove that they're definitely in the same ratio. Certainly, proving they're in the same ratio makes it a little bit easier, but even if you assumed it and went from that as a starting point, it would probably lead you to the right answer. But a pretty tricky one there. Good luck if you could follow that pretty quick explanation, but you're having a look at them tomorrow. Hopefully that gives you a few ideas you might be able to try tomorrow anyway. Cheers.